Hi all, thanks so much for joining. This is our webinar series, Topics at the Nexus of Climate Change, Fisheries, and Blue Foods. And this webinar series is jointly hosted by the UN Ocean Decade Action's Blue Food Futures, FishSCORE, Supreme, SmartNet, FishMIP, and Becky. And this webinar series highlights current efforts and challenges at the climate fisheries nexus. Presentations over the course of the series range from data-driven efforts to better understand oceanographic and biological changes affecting fisheries, to how the results can be used to inform fisheries management, aquaculture, and sustainable food decisions, to the many ways that people and broader communities are being impacted by and adapting to changes in the marine ecosystems and marine resources use. So thank you for joining us for today. Today, we're going to focus on ocean data collection to support climate resilient fisheries in the UN Ocean Decade. And we have two presenters today. The first will be presenting on an Ocean Decade project and a very large data collection effort in the Western Indian Ocean. And our second speaker will be focusing on how data like that project and many others can be shared and the results shared through the Ocean Decade. So thank you to both of our speakers. Our first speaker is Joseph Kamau, and he's a principal research scientist at the Kenya Marine Fisheries Research Institute, where he's dedicated over 30 years to advancing our understanding of marine ecosystems, particularly within the Western Indian Ocean. As the head of the Oceanography and Hydrography Department, Joseph specializes in biogeochemistry and environmental sciences, addressing critical issues surrounding climate change and its effects on marine resources. So thanks so much for joining us, and I will get that presentation up and ready to go. Can everyone see that? That's great. All right, Joseph, please take it away.
Okay, good evening, good morning, and my name, as it has been said, is Joseph Kamau from Kenya Marine and Fisheries Research Institute. I'll be presenting a work that has been done by a number of scientists, and this encompassed two projects: the Solstice project, which was hosted under the National Oceanographic Commission of Southampton, as well as Sapphire, which was sponsored by UNEP. And the main focus was actually to understand the productivity systems within the Western Indian Ocean, and more so now focusing on the North Kenya banks. Kenya has a short coastline, and most of the fishery is actually located in the north, where we have the North Kenya banks, and the south, where we have the influence of the Pemba Channel. So those are the main fishing grounds that actually drive fishery in Kenya. So we can move to the next slide. So So just as a background, and of course, this is not only limited to Kenya, North Kenya banks, but climate change is projected to cause significant reductions in global fishery catch within the 21st century. But the shortfall is that little is understood about how climate change is going to impact the tropical fisheries, and considering that this is a support system that actually supports quite a number of livelihoods, and more so within the North Kenya banks, that is the main fishery grounds in Kenya. So the drivers to these impacts are mainly the rising temperatures. We are having the Indian Ocean temperatures rising quite high, and the reduction in primary production as a product of that, deoxygenation, ocean acidification. These are major drivers that are going to impact actually they cause impacts on the fishery as well as the ecosystems that supports this fishery. So the next one. Can we move to the next? Okay, so just so that we may understand the North Kenya banks. So the North Kenya banks actually is within the territorial waters, and that system supports mainly fisheries, artisanal and semi-industrial fishery, and it's actually mostly supports the fishery within the communities that are bordering these systems. The North Kenya banks actually is also within the tuna, falls within the tuna migratory path. And the kind of the research that we conducted through those two projects that I've mentioned, we are able actually to locate, to understand the kind of spawning activities that happen there and the diversity within that. So it's quite a support system that actually supports the spawning of commercial fishery. And this year we are talking about the tuna and tuna-like species. And having said that, that means that the system plays a crucial role in the management of or the propagating of the migratory species, because before that, not much was known about the North Kenya banks are actually supporting the propagation of the migratory fishes, and more so here talking about the tuna. So this is something that is of interest, especially when it comes to the commercial fishery and tuna. More so talking about the tuna. So we can go to the next one. So climate change, even when we're looking at this, climate change is already altering marine ecosystem and changing the intensity and timing of coastal upwellings. This will impact fish migration patterns, recruitment, growth, distribution, and abundance, as well as also affect the predator and prey relationship. So this is something that needs to be understood, because unless we understand what the dynamics that are involved, we cannot be able to manage the resource effectively. So as I said, the North Kenya banks has an abundance of lava and taxa richness and diversity, and this makes it a distinct region that plays a key role providing favorable reproductive and nursery habitat for a wide range of commercial important fisheries. This is what I've been pointing about. And they support system. The margins also support, act as a support system to this complex ecosystem. And here we're looking at the mangrove habitats, the seagrass, as well as the coral reefs. These are nursery grounds, as well as providing avenues of the juveniles to be able to hide from the predators. So these are important key critical habitats, and much needs to be done to be known about their resilience, as well as understand how they can be sustained and sustainably be preserved because of climate change. Because as climate change comes in, it comes in with a lot of aspects. Floods come in and they may smooth out some of these critical, nearshore critical habitats. And the high temperatures may also cause bleaching of the corals. And so there needs to be understood the kind of resilience of these critical habitats and what can be done so that we can mitigate against losses of these critical habitats. We can move to the next one, please. So I've just been introducing the North Kenya Bank so that we may understand the kind of what we're looking at, and so that when we talk about the concerns, we already know the kind of habitat that we are talking about. So the North Kenya Bank, as I say, is an important ecological habitat. However, limited studies have been conducted, and the system, and not only that system, but the Western Indian Ocean is highly connected to the ABNJ, and this is something that needs to be looked into, because whatever happens within the ABNJ at timescales of less than 1 month, the impact is felt within the Western Indian Ocean. So it is highly impacted by whatever happens within the ABNJ. So, but then we have the BBNJ, and I think we need to take advantage of the BBNJ so that we can address some of these concerns that we are looking into. So the BBNJ, we can look at maybe having the high seas, what do you call them, the management areas, and so that we can manage some of these biodiversity rich areas, so that we don't impact much of the Western Indian Ocean because of that connectivity. And the connectivity is actually because of the kind of current systems that are interplay within this region. So this system is driven by the monsoon winds, because it's driven by currents that are driven by monsoon winds, and we have the East African coastal current and the northeast monsoon. We have the southeast monsoon and the northeast monsoon. Sorry. So within the southeast monsoon, that happens during the summer, and the northeast monsoon is during when it's the rainy season. So these two have different dynamics of these two monsoon seasons behave differently and have their own ways of replenishing the productivity within this region because of the different dynamics that happens within their separate seasons. So the other concern is actually undeveloped market outlets. So there are times when fishermen fishermen get a lot of harvest, but they are not able to. They are limited. They catch because of the high harvest, but they don't have an outlet to take the fish they catch. So that's another problem. So there needs to be clear management structures to ensure sustainable exploitation of these. And this is looking at the social dynamics as well as the socioeconomic dynamics, so that we can critically look at the loss in catches as well as enhance market structures. So we can move to the next one. Next slide, please. Next. Just move to the next one as well. Okay, so we were looking at the connectivity. This is just to point out at what I've been, just to emphasize what I've been talking about. No, the previous one, please. The previous slide. Yes, that one. So here is just to emphasize and actually to look at pictorially how the Western Indian Ocean is actually highly impacted by the ABNJ. You can see that activities within the ABNJ at scales of even half a month and 1 month, the impact is already felt within the Western Indian Ocean. And apart from that, we have also found being able to actually get concurrence with the kind of research that we have done on microplastics. And we know microplastics are drifters. So we're able to see that there were high concentrations of microplastics at the edge of the EEZ, as opposed to us nearer the land. So that shows that the microplastics were actually coming out from outside the EEZ, and that is the ABNJs, and not the much of the concentration, the masses of the microplastics were actually coming out from the ABNJ and not from the land, as we might have assumed. So that also gives us the indication of what kind of impacts the ABNJ can have on the coastal systems. And this actually is a concern that we need to look into, because the connectivity is something that needs to be to raise concerns, and maybe also working on the BBNJ, be able to come up with structures to safeguard the Western Indian Ocean. So we can go to the next slide, please. Okay, so what we're looking at, and there are two figures here which shows the kind of current systems that influence the dynamics of the North Kenya banks and the coastal systems of Kenya. During the northeast monsoon, we have the confluence. The Somali current reverses and meets the EACC, the East African Coastal Current, and then you have the confluence. And the confluence actually pushes water masses towards going towards the east. And the masses of water that moves out, of course, has to be replaced, and that triggers upwelling, or the movement of cold waters rich in nutrients to the surface. And this is what drives productivity. So this one is a system that is driven and dependent on the monsoon winds and the strength of these two currents. You have the Somali current and the East African coastal current. So it has been postulated that with the advent of climate change, the East African coastal current will weaken. And as the Somali current strengthens, that means that the confluence will shift southwards because of a weaker East African coastal current. And now if the confluence moves southwards, that means that the upwelling will also move southwards, and this will have an impact on the productivity of this system. So that is when you look at the northeast monsoon. But then you also have the southeast monsoon when the Somali current reverses and moves northwards, and in essence actually causes the EACC, East African Coastal Current, to accelerate. And when it accelerates, it comes into contact with the North Kenya banks and causes a perturbation of that system. And the North Kenya banks also has the influence of the Tana River, which brings in a lot of sediments. About 7 million tons of sediments come in. And this is also another pool of nutrients that come in. And so the perturbation that is affected, that comes in with the high speeds of the reverse Somali current pulling in the East African coastal current, will actually drives productivity in this system. And that is what drives the tuna migration to this system, because tuna migration actually migrates during the southeast to Kenya, and that is in July. That's when you have a lot of tuna coming in with in the coast within the coastal area of Kenya. This is mainly attributed to that kind of perturbation and causing the nutrients enrichment in the water column and that productivity. So that gives this system quite a resilience, because it is driven by a number of systems that drive it. So that actually will give it that resilience, even with the advent of climate change. We can move to the next one, please. Forward. So these are recommendations. So we're recommending, because as I said, North Kenya Banks is one of the key fishery resources in Kenya, and we only have two that are key for us in Kenya. So we need to develop a fishery management plan which considers the variability and the kind of variability I've been talking about of the North Kenya banks, then there were upwelling associated. So, and as well as the uncertainty of climate change, because climate change, as I say, the productivity of these systems are driven by wind-driven monsoon currents. So they are bound to be affected in time scales, as well as the strength of these currents will also be affected. So how will these systems be affected, and how will the fishery be affected? These are the questions that needs to be answered, and allow for adjustment in management measures on how to be able to be able to manage this resource effectively. So we need to understand the climate stresses, their impacts, and this uncertainty, and the North Kenya Bank's upwelling strength and location as climate change progresses. So where will this upwelling happen? And if it happens to shift, will this productivity or these fishery grounds also shift with the confluence? So these are the questions that we need to understand. And that will also drive us to have an adaptive capacity for emergent fisheries, so that they can respond to natural variability, as well as minimize and cope with and recover for the consequences of these kind of uncertainties. So apart from that, we also need to have a strengthened remote sensing, so that we can have these PFZs, understand how we can effectively advise on where to go fishing, so that that is also makes it cost effective to fish in our waters, considering that the fishery may diminish with time. So we also develop a risk-based management approach to cope with good and bad years, establish management mechanism to protect stocks from overfishing, so that we can also be able to cope with the bad years. Can move to the next one, please. So as we say, we from the research that we conducted, we have seen that the North Kenya Bank is an important ground and upwelling system that supports the tuna, this commercial fishery, and so IOTC needs to be well documented in IOTC, and develop a management plan for the system, as well as have it as one of the upwelling systems that needs to be kept in watch, because so far it has not been focused that much, but it is an important system that needs to be put into the limelight, so that much can be understood about this system, considering that it drives this commercial fishery, migratory fishery, which is the tuna. Then we can move to the next one, please. Okay, so having said that, we're now looking at the elephant in the room, which is climate change. And climate change has been postulated to actually affect this fishery into the future. And more so considering the shifting. Much of the emphasis has been on the shifting of the confluence, because the confluence actually drives upwelling. As the water mass moves eastwards, that causes a mass flow that brings in the cold waters from the high productive from beneath, with high nutrients to the surface, and that actually causes the replenishing of the waters and causing productivity. So how is this going to happen? Because according to models, it has been shown that this confluence, as the EACC weakens, the East African Coastal Current weakens, the Somali current will push the confluence up to Zanzibar, and that's been said. So that means that the northeast monsoon, during the northeast monsoon, the productivity within our region in the North Kenya banks will not be as it is right now. So that will affect the fishery there. So how is it going to happen? These are questions that needs to be answered. And for us to understand this, we need to have in-depth on-site sampling so that we can actually understand what is really happening in situ, other than just the models describing what will happen. But it has also been said that in comparison with other areas, the Indian Ocean, the Western Indian Ocean area has cooler mean sea surface temperatures owing to the strong monsoon winds and the resulting upwelling over the Western Indian Ocean. So also these are questions that are going to happen. So if the confluence moves south, is this going to be the same? Are the waters still going to remain cool within the North Kenya bank? So these are key critical concerns that will need to be answered as we move and progress towards managing this resource. And of course, the migration of several coastal and ocean pelagic fisheries is also known to follow changes in ocean circulation pathways. So what will happen to the migration of the tuna? Will they also follow the confluence, or what will happen? So these are questions that are actually perturbing and needs to be understood. How is it going to happen, and how is climate change going to affect the fisheries within this region? So and as I said, the research that we did was encompassed quite a number of disciplines. And there was a model that actually looked at put in about 43 fisheries, commercial and artisanal. And within that model, it was projected that there will be mass reduction of fish biomass in Kenya and Tanzania in the absence of climate change mitigation. So these are very strong concerns, especially for the fishery in Kenya and Tanzania. Move to the next, please. Next slide, please. Next. Okay, so this is just to emphasize what I've been saying. There is a warm pool passing through the Indonesian throughput, and you can see also the Western Indian Ocean also warm pool is also following that trend. So you can say that that warm pool is actually influencing heavily on the water system. I mean, on the temperatures within the Western Indian Ocean. But the concern here is when you look at this warm pool and the Mascarene Plateau. The Mascarene Plateau is actually where the key spawning of the tuna happens. So if that system heats up, what will happen with the spawning of the tuna within the Mascarene Plateau? There has been some suggestion that the tuna spawning will move southwards, where we normally have an unexplained, below Madagascar, you have an unexplained productivity system that others have said that is actually driven by burning of the forests during that season and wet dry deposition and wet and dry deposition of those nutrients causes that that productivity system. We'll look at it when we go to the map. I'll show you what I'm talking about. So this is what I've been talking about, define the confluence. The confluence will shift. Models analyzing present evidence that the position of the confluence is highly variable. Of course, it varies because it's variable because it's dependent on the strength of either of the two currents, and of course the currents also depend on seasonality, how the winds are moving, and of course it keeps on moving up and down. So that's, we can move to the next one because I've been talking about this. Okay, so the ecosystem shift, and we have actually dwelt on this. how the model has postulated that there will be reduction of fishery within Kenya and Tanzania. Fish biomass are projected to reduce up to about 70%, and this is actually alarming. And the model actually took into consideration biogeochemical properties such as temperature, salinity, pH, chlorophyll, and velocities. Those were taken into consideration when coming up with the products of the model that actually postulated that these two countries will lose about 70% of their fishery in the absence of climate change mitigation. We move to the next one, please. So these are the upwelling systems that actually drive productivity within the Indian Ocean and Western Indian Ocean systems. The system that I was talking about is the East Madagascar bloom. I hope you can see it. Move backward. You're one slide ahead. You're one slide, 2 slides ahead. Move backwards again. Yeah, so you can see the East Madagascar bloom. Oh, one forward. One forward where you have the map. Yes, that's a place. Yes. So maybe just to recap, you can see the Mascarenhas Plateau, because I know this is not the system might not be clear to all of us. So you see the Mascarenhas Plateau is actually a high raised area, and we saw the warm pool coming towards the west and approaching the Western Indian Ocean. So this warm pool will come into this shallow area, which is the Mascarenhas Plateau. And the Mascarenhas Plateau is an important area where we have the spawning of the tuna and tuna-like fishery. So this is a system that supports the tuna fishery. So what will happen to it? This is a question that has been addressed, and most some are similarly are indicating that the spawning might move to the East Madagascar bloom. The East Madagascar bloom, as I said, it has not been well understood what drives the East Madagascar bloom, and some have indicated that it's actually caused when the forest burn, and then we have dried and wet deposition around this area that causes that bloom. So the indication that the spawning will move southwards to the East Madagascar bloom because of the rising temperatures. So these are questions and need answers, and these are concerns. And that, of course, of course, it is understood that changes in these systems may also causes changes in migration dynamics of the fishery. So it's not far-fetched, it might happen. These are key questions and needs to be addressed and understood critically. So we can move to the next one. But it's a major concern if temperature continues to rise in these areas. So this is the publication that postulates a reduction in catches in the two countries. You can see how the bottom temperatures continue to increase, as well as primary productivity reductions. The reduction in the primary productivity, the increase in mean bottom temperatures, these are going to drive the MS values to cause fishery to decline. And we're looking at all these key fisheries, the big eye, all these tuna and tuna-like fishery are going to be impacted because of climate change. So something needs to be done. We need to mitigate against climate change impacts. Otherwise, as postulated by the model, we really it's a big concern towards the fisheries within Kenya and Tanzania. But having said that, we also need to understand that the system is also resilient and is driven by a number of local systems that might also cause it to be resilient and not so detrimental to as the model predicts. So you can move to the next one, please.
Joseph will need to wrap up in the next minute to have time for our other speaker.
Okay. Sorry about that. Yeah. So a quick one. So other research has indicated that they will actually be productivity enhancement, especially within the Somali upwelling systems, and in the upper latitudes there will be an enhancement of productivity. So we can move to the next one. So as I talked about resilience, the resilience is actually needs to be understood in that the North Kenya banks, apart from having two different dynamics during the two seasons, the Northeast and the Southeast monsoon, we also have influx of the nutrient pool by the Tana River, which brings in about 7 million tons. And these ones are also a pool that also drives the productivity within this system. You can move to the next one. So yeah, these are just the publications that we were able to come up with. Several publications that actually informs the kind of research that we did and a clear understanding of that system, the North Kenya banks. So we'll just move to the next up to the acknowledgement because of time.
Thank you so much for your presentation. We'll hold questions till the end. I want to go ahead and introduce our next speaker, Adam. If you want to start sharing your screen as I give your introduction. Dr. Adam Leadbetter has over 19 years of experience in marine sustainability data management, and he has developed a strong network in Ireland, the UK, Europe, and globally. He's an expert in the design of marine data and information systems, and has worked extensively in connecting them with wider open data initiatives. Adam is keen that these data systems will fulfill the needs of users and has led diverse groups of stakeholders in the co-creation and design thinking approaches to identify their requirements. He has also worked alongside UNESCO's International Oceanographic Data and Information Exchange in different projects over 10 years. So Adam, I will give it to you if you want to share your screen and give your presentation.
You're muted, Adam.
Yeah, can you see the screen now?
Looks good.
Great. Excellent. All right, thanks everybody. Thanks Claire for the introduction, and thanks everybody for the invitation to be here today. So my colleague Margarita is on the call as well, and we are here from the Decade Coordination Office for Ocean Data Sharing. And we just really wanted to introduce the work of the Coordination Office, but also, I guess, give a few pointers to how we see data sharing happening within the decade as well. So yeah, just to say as well, we're here with the support of Fondation NG as well, who fund our work. So I thought the previous presentation was really interesting, kind of answering some of these questions. What stories could we tell if we had more ocean data, if we had more access to ocean data? And so I think there were several really good examples of how we could address threats to the marine environment in the last presentation. As we looked at the models, we could see how we might understand trends, how we might forecast climate change, how we might forecast fisheries changes as well, using more data. One area that I'm particularly interested in is kind of marine spatial planning, and bringing in all kinds of different data to allow plans to be developed to look at where the ocean can be sustainably developed, to look at the interactions between different ecosystems and different systems within the ocean as well. So when we have more ocean data, when we have more widely shared ocean data, we can tell better stories, more coherent stories, more accurate stories around all of these areas. So I think with the decade, there is a proposal for a kind of decade digital ecosystem, and if you look in the Vision 2030 documents, and particularly around Challenge 8, we see there's a need for a digital infrastructure around the decade and around global ocean data in particular. So we really want to use the decade as a way of furthering this and as a way of developing something with the systems that already exist, so that we can increase access to ocean knowledge and information. We can increase the findability of those things using well-known systems. That we can do things like mapping and quantifying ocean risk. And we heard in the previous talk quite a lot about the risks to fisheries, the risks to, I guess, to livelihoods as well, that happen because of things like climate change. But also we know that corporations want to be able to map and quantify their risk that's ocean-based and nature-based and climate-based more and more as well. So we'll see different users taking up these data as well, and also to promote the resiliency and the sustainability of the ocean. So again, within the decade, and I think we all kind of recognize some of these things, but we've identified several challenges that faces in terms of ocean data. The ocean is often undersampled, and the measurements that are collected are not always shared. And again, that's for good reasons. In lots of different places, we recognize that scientific research needs to happen and publications need to happen. We also recognize that commercial bodies are collecting some of this data, and so they're not always sharing either, because there's sensitivity around the data. We also think have identified that there's a lack of knowledge on the relevance of ocean data, how to find it, how to use it. And often that stems from the fact that when we put data out there, it's not sufficiently user-friendly or well integrated. And then forecasting services don't get to use the data because it's not integrated, and then they're not sufficiently extended to serve the needs of different actors around the ocean. So we have a couple of steps to try and address some of these things between a number of the decade coordination offices and decade collaborative centers. So being able to come onto webinars like this and work with decade actions like the ones who are leading this kind of seminar series is really helpful, because we believe that it helps us increase the demand for ocean data. It also helps us to spread the word about how to get better data into the systems that exist. And then we were working with other decade actions and IOC programs around integrating the data. And then I guess particularly with programs like the Digital Twin of the Ocean and the Decade Collaborative Center for Ocean Prediction, we look at how do we transform some of these data into information. We've also at the center here put the public and private sector as being really important. So obviously, a lot of research is publicly funded, but we recognize more and more that the private sector, companies, enterprises, are organizations that have data around the ocean and also want to use data around the ocean. And so within the decade, there's a corporate data group, and they have already published guidelines on sharing bathymetric data. And that's helping with the Seabed 2030 program. And we're also looking at observations of marine megafauna and how to share those. And there'll be other guidelines coming from that corporate data group to help unlock some of the archives of data that we haven't been able to previously access and use together. So we're doing this through defining and implementing good practice. We're doing this through specifying case studies, specifying data standards, working with the Ocean Data Information System and other programs around the decades to create some common tools, and then developing joint architectures and joint ways of working with other decade coordination offices and collaborative centers. So in the Vision 2030 document, there's this kind of vision of the future of a digital representation of the ocean, and that's kind of challenge 8 of the decade. This picture I've taken from the European digital twin of the ocean, but it kind of shows what an interactive replica of the ocean, what that digital representation of the ocean might bring, where we have observations and they lead to data which feed our models and our visualizations, and then we can extract knowledge from that, which then in the real world brings us back to decision making and actions, and the results of those generate more observations because they dictate how we monitor the ocean, how we observe the ocean, how we interact with people who are using the ocean, which brings us all the way back around to more data that can feed our digital representation of the ocean. So this is just a kind of schematic of how that digital representation of the ocean might interact with the physical world as well. So in the Decade Coordination Office for Ocean Data Sharing, we have three main areas that we're looking at. So the first is to coordinate decade actions, and then we have a community of practice around data and information management and sharing. And I'll say a little bit more about that later. If you're collecting data, creating data in the ocean, we'd really encourage you to join our community of practice so that we can help get information to you about and support you in how to do that. And then we're supporting the implementation of the decade's data and information strategy. And also we're looking at training courses for capacity development, and also how to unlock some funding opportunities and resource mobilization around some of these things. So really, like, this is probably the bones or the meat of the talk for today, just the next couple of slides, and I'll just spend a couple of minutes going through each of these. But we recently published in our community of practice some data sharing guidelines. There's kind of 6 points in there. So and again, people can follow up with us afterwards for more detail on any of these. We can't in 15 minutes, 20 minutes tell you how to do all of these things, but it's just a starting point for today. And so first of all is to develop a data management plan. And we know from surveys that have happened of decade actions in the past that data management planning is something that people find very hard. And so please, if this is something that you want some help with, do contact us afterwards. But a data management plan is there to help you to organize, plan how your data are going to be managed and documented and then shared in the future. And we recognize that from a kind of IOC level, the guidance that's been out there has been out there for a long time, and we're hoping to get some new guidance out on how to do a data management plan later in the year, with help from a broad community of experts who are helping us to develop that. Yeah, where you can then follow data standards, use established formats and standards and conventions yeah, I come from a physical oceanography backgrounds, and so climate and forecast is something that we use there. But for observations of fisheries and biodiversity, then the Ocean Biodiversity Information System, OBIS, is there, and they have standards that can be followed. And then we want to, where possible, ensure the data can be accessible. So where it's appropriate, following the IOC data policy of sharing data with minimally restrictive licenses, we encourage sharing data in open repositories. And again, for biodiversity data, then OBIS and the various OBIS nodes provide a great mechanism and a great support system for doing that. Yeah, we need to consider data restrictions. So we need to think about, as we're documenting and planning for our data, we need to think about how they can be managed and documented to reduce the number of restrictions placed on the data, so that we can help with sharing, but obviously while respecting the rights of any data owners, data subjects. Yeah, so it's again, the IOC data policy is about minimally restrictive data sharing, and minimally restrictive data sharing. The fewer restrictions we have as we share the data, the more applications, the more insights we can enable from the data later on. Many of the repositories will have metadata requirements. The Ocean Data Information System has its own metadata requirements, its own data about the data that needs to be filled out. And so again, we can help with that, and the data management plan should kind of help to point you in the right direction of how to fill out those metadata. And then really important, if we're sharing data, is to think about how it's going to be attributed afterwards. How do you get the recognition that you deserve for collecting the data and putting it out there and sharing it? So establishing practices to ensure data attribution. So persistent identifiers, digital object identifiers that can be cited in the literature, just as you would for a journal paper. You can cite data sets that have digital object identifiers, DOIs, and they follow through in the same citing metrics as you would for a journal article as well. So we have some resources available online. We have a on our website, and the website link will be on one of the final slides here. We have a toolkit, and there's lots of information about data and information in the decade, guidance around some of these things that we've spoken about, how to find training courses, how to find the data that you need to do the work you want to do, how and where to share your data, and there's some useful case studies and examples on that website as well. Yeah, and we're starting to develop things like this kind of data sharing matrix. So helping people to understand and navigate through what kind of data you're working with, which geographic region you're working in, and then where to find guidance based off those things, and the data standards that are published in various thematic areas or field specific areas. And then finally, we have a help desk, which operates both virtually and physically. So you can see there ocean data sharing DCO.org. That's our website. That's where you can find the toolkit and the things that we're looking at, that we've spoken about, and you can send in questions there to the help desk if you have trouble with any of these things. But also at the UN Ocean Conference then in Nice in the summer, we'll be running this is a physical help desk, and last year at the Decade Conference in Barcelona, it was a physical presence. So yeah, please do let us know any questions that you might have around this. The way that the communities of practice are working at the moment, they're being moved to LinkedIn in the Decade rather slowly. So I would say, please follow what we're doing there, and we can join in the conversation as well. So then, yeah, just there's both me and Margarita who are working on this, and yeah, we're planning then on providing updated guidelines on data management plans and data attribution in the next few months. We're working on new data standards around ocean forecasting, but also some of the conversations we've had with actions, socioeconomic data, citizen science data as well. We'll be developing some new data standards there. We're working with a range of Decade coordination offices and collaborative centers to engage Decade actions, being involved in webinars like this just to raise awareness, but we're also organizing some of our own webinars as well with some of the other Decade actions, just to show some case studies about what happens when you share your data. So it'd be great if you can follow along and join those. And we're also going to be providing some training courses later in the year. There'll be in-person ones, and there should be some support for travel to those. So again, please keep in touch with us so that you can keep an eye out for those. Yeah, and the help desk is there to use as well. So thanks for your time, and yeah, please do be in touch with any questions that you have. If you're a Decade action, we'd love to talk to you, and if you're not, we'd still love to talk to you and help share your data so that we can address some of those questions that we went through at the beginning, and tell much better stories to all of the people who are involved in using the oceans, and so that we can have the data that we need for the ocean that we want at the end of the decade. Thank you.
Thank you so much, Adam, for the presentation, and also to Joseph. Really appreciate both of your time and everyone's time here. We have time for maybe 2 or 3 questions. And Stephen, go ahead.
Yeah, thanks, Joseph and Adam. Those were fantastic talks. Adam, just one concern I have is, we're halfway through the ocean decade at this point, and one of my hopes is that a legacy of the decade will be existing functional infrastructures, whether for data sharing, capacity development, networking, et cetera, that can kind of outlive the ocean decade. And
Yep.
and I wonder if you're thinking about it in that way at the Decade Coordination Office, and also what you're thinking about, potential resources moving
Yep.
forward beyond the decade. Yeah.
So that's a great question, and it's exactly one of the things that we are thinking about. I think we don't want to build anything new that is solely for the decade, because the decade kind of finishes, and then what happens to it. So we're working very closely as the Decade Coordination Office for Ocean Data Sharing, but also Ocean Observing and the Collaborative Center for Ocean Prediction. We're working very closely with the International Oceanographic Data and Information Exchange, IODE, and OBIS. And then we're working very closely with the Global Ocean Observing System as well, so that everything that we are developing, the infrastructure, there's a data architecture that's in development, there's an atlas that will be being developed, being developed very soon. All of these things will be developed with the core program components of IOC so that they can live beyond the decade. And so that's exactly the thought process that we're going through. Yeah.
Thank you.
I hope that answers the question.
Just for time's sake, I'm going to go ahead and move to Paul Watts. You have a question. If you want to unmute yourself, please go ahead.
Yes, thank you to the presenters for those presentations. It was really interesting to see the connections between them. Joseph, I had some questions about the tuna and productivity in the northeast monsoon and southeast monsoon. We find in the Philippines that the changes in the monsoons have a lot to do with the tuna harvest. Looking forward, which do you expect to be the most productive in terms of those two systems, the colder southeast monsoon current?
Yeah, actually, it is the southeast monsoon that is more productive, but most emphasis is given to the northeast monsoon, because the northeast monsoon, you have the confluence and the productivity is evident by satellite imagery. But the southeast monsoon, the productivity actually, it's you take CTDs, rosettes, and you sample the nutrients. The productivity actually breaks through midway through the water column, and that is what drives the fishery during this time, and that's why you have the tuners coming in July. So there are two systems that have different dynamics in how they perturbate that system. Whereas one brings in cold waters from below because of the water mass moving eastwards, this other one comes in with force and strikes. There is the topographic forcing that causes perturbation of those nutrient-rich sediments that have been deposited by the Tana River. Yeah, so for me, I think it's the southeast monsoon that is more productive.
That seems, yeah, that's what I would expect too. How do you see that changing with climate change? And I'm wondering, do you see ways of systemizing training for fisher folks so that they can be involved in responding to the climate change challenge?
Yeah, the only shortfall is that during the southeast monsoon, the waters are very rough, and because of the nature of the local fishermen, their vessels are not well fashioned to actually be able to sustain rough seas, and so whereas the fishery is highly productive during the southeast monsoon, the local fishers don't fish during the southeast monsoon. They actually fish during the northeast monsoon. So that is, yeah, that is a dilemma that we have. Maybe the that aspect needs to be addressed. Maybe some staple vessels needs to be given to the local fishers so they can fish during the southeast monsoon.
Interesting. Thank you.
I hope, yeah. Thank you.
Many thanks to both of our presenters and for everyone for participating. And we'll be posting this webinar on our website in the next couple of weeks if you wanted to revisit any of the information or to get in touch with either us, the co-hosts, or the presenters themselves if you had any follow-up questions. And hope you can join us in late April for our next webinar. Look out for the announcement for that. Will be coming up in the next couple of weeks, and hope everyone has a good day or night, whatever time zone they are in. Thank you all.